Question 8. The width of a rectangular sports pitch is x meters, x greater than 0. The length of the pitch is 20 meters more than its width. Given that the perimeter of the pitch must be less than 300 meters. Form a linear inequality in x. So if I draw the pitch, and this is x here, that must be x plus 20. And the perimeter of the pitch will be x plus 20 plus 2x. And that must be less than 300. That's what we've been told to do. So I could expand that. Now I get 4x plus 40 minus 300 will be less than 0, and that implies that 4x minus 260 is less than 0. Given the area of the pitch must be greater than 4,800 meters squared, form a quadratic inequality in x. Right, so the area of the rectangle would be x times x plus 20, and that must be greater than 4,800. And if we'll expand that, that implies x squared plus 20x minus 4,800 must be greater than 0. C. By solving your inequalities, find the sets of possible values of x. Right, for 8c, we need to solve the inequalities here. A is equal to 1, B equals 20 is minus 48,000. I want to find AC. AC is minus 48,000. I need two numbers I can multiply together. Well, 48 is 8 times 6, which means I'm looking for 80 and 60. I want to get plus 20, so I want minus 60. And therefore, I want to put x here and x there. So now I need to replace 80x minus 60x with 20 plus 20x. X squared plus 80x minus 60x minus greater than 0. So there's a common factor here, just x. And there's another common factor here, minus 60. So what I need to do is take out the common factor. X is common, so I get x minus 80 minus 60 is common, so I get x minus 80 plus 80. There is a plus in x plus 80 in the first one, and that's greater than 0. Now I've got common factor here. X plus 80 are common factors, and what's left will be x minus 60. Okay, so I'm going to get x minus 60 is left, and x plus 80 must be greater than 0. So my values are, the factors are, x is greater than 60, comma, x is greater than minus 80. So those two values can then help me to write down the inequalities in this case. So if I quickly sketch that curve, just a quick sketch. If I get minus 80 here and 60 there, and my intercept is minus 4,800 somewhere, minus 4,800 somewhere there. So when I'm sketching the curve, because it's positive curve, going like that, but we want the value of x greater than 0. So we want, so it's not going to be equal to any of those values. So this value here is 6, this is 60, and that's minus 80. So to mark the point, so that's the point, that's the point. Because we needed, it's not equal to 80 and it's not equal to minus 80, it's not equal to 60, so we select open circle. And we want it greater than, so we're looking for values that are greater than, so that's greater than 0, and that is greater than 0. You can see, so that's greater than 0, that is greater than 0. So the domain, because they're asking for sets of value, possible values of x, that will be the domain. So that's the domain will be open curly bracket. It's not a square bracket. If it's equal to minus 80, then you get a square bracket. X colon x is less than minus 80, close curly bracket. You then have union. Union means or plus, open curly bracket for the second part, x colon, because we're talking about x-axis, x is greater than 60, close curly bracket, and that's the set values for x. So the points we've just written are from minus 80 down and from 60 upward. That's the x values we want. That's what this is explaining. We always start with the smallest value. That's why we start with minus 80. Union means because there's a gap between here, so we uniting the two together. So union, and then the right hand side here. We always start with the left hand side and then the right hand side, since we write from left to right.